Let's shift gears and look at on the model validation side. What is unique about MQA? MQA is the industry standard measurement and Foundry quality tool. It covers 5 critical model validation areas shown here. Data check, looking for the expected range. Is the data smooth? No kinks. Model quality assessment, looking for accuracy, trends, parameter range, robustness. On the consistency is the third area. We're comparing across libraries, models, simulators, technologies, foundries. On the large signal side, MQA can test, simulate, and verify against measured data one-tone harmonic balance, looking at power out versus power in, power added efficiency. P1dB. On the two-tone harmonic balance side, it can look at intermodulation distortion, IMD, output or input inferred IP3, for example, and look at the spectrum. And last but not least, it can look at the report generation. It can do reports, and you can customize them, and the defaults are pretty great. It's going to give you what you need to share with the rest of your company. It can even do things like the wafer acceptance test, the NP plot shown here that has local and global statistical variation. MQA, to summarize, MQA is a qualification tool. It's knowledge-based, rules-driven. It can validate your library and measure data. It's a documentation tool. You can easily overlay measured data with the simulated data and check for the quality of the model. It's easy to customize a report. It's a design interface, Foundry interface tool. You can compare across all those areas, libraries, models, simulation, foundries, technologies, versions. And finally, it's a model QA results sharing tool. It's a bridge between Foundry and Design House, and even communication between different design groups. Let's take a virtual animated picture of how MQA works. First of all, we start with MQA in the middle. A device modeling engineer is going to bring SPICE models to the table, SPICE libraries to the table, and sometimes not, device model engineers will bring the measured data. The heart of MQA is the knowledge rules file driven approach. It's in sync with the latest technology, and the rules are actually easy to manipulate. They're almost like text-based, but it give you a full recipe for the latest technologies, and if you need to customize them, you can, or you can just use what comes with the examples and the extraction examples in the QA projects. MQA has the ability to auto-generate netlists and will run simulations on all your favorite simulators, or if you don't have access to that, you can use the very robust internal SPICE simulator that MQA comes with, very handy. It will run the rules files, run the project against all the rules files, and it will generate reports. And voila, you're ready to go. I just want to point out here too, we offer an extensive set of step-by-step YouTube videos that you can access, and here's the links for that, to how to use MQA. Context is very important, right? So instead of going over in detail this user interface slide on how MQA works to create a project, apply rules, let's use this as a lead into our demo that's coming up next. Suffice it to say, the demo will show you walking through a BSIM4 QA project build. It's going to use these 3 windows extensively and walk you through the steps to do so. The Library Explorer, Lib Explorer in MQA. It's going to use the Create QA Project Wizard and show you how the steps that it walks you through to do that. And it's going to bring everything back and the Lib Explorer included into the MQA main window, where you can check rules and see how things came out and look at the results and the plots and generate reports. Let's go ahead and do our MQA Quick Start demo.